Identifying organic compounds. Organic compounds can be identified by their functional groups and how they are connected to other atoms. The next slide shows the basic structure of the molecules that you will be expected to identify. The functional groups, either alone or combined with another group, are boxed in red. The oxygen here is a functional group only if it bridges between two carbons, like in an ether. This would be a fantastic slide to print out and save for future reference. So you can either go to the PDF and print it, or I'll pause here a second and you can pause, take a picture of it. So here we go, count a few seconds. And then I'll talk about what we have here. We've listed the various molecules on the left side, alkanol through ether, and then we describe what functional groups are involved. And you can see there's a lot of carbons double bonded to oxygen. But then it's a little different how they connect to the rest of the molecule. Here you have hydroxide connected to an alkyl group. Here you have this carbon-oxygen double bond between two alkyl groups. Here the CO is connected to an H and a terminal carbon, the end of the chain. Alkanoic acid, you have the carbon-oxygen connected to a hydroxyl group. And they're circled in red so you can identify them. The alkanote, the carbon double bonded oxygen connected to an OR, where R can be any alkyl. And finally ether, which is a single oxygen bonded between two alkyls. Let's show some examples. Look at these four molecules and decide which is an alkanol, and we'll show you the answer on the next slide. For all of these, if you need to pause the video before you go on, go ahead please. Okay, so what's wrong with the first one? There's no OH group. The second one over here is correct because you do have the OH group, which we've highlighted in yellow, connected to an alkyl group. This one looks close, but the OH group is connected to a carbon-oxygen double bond, which is a carbonyl group, so that is not an alkyl group. And finally, the hydroxyl group over here is connected to a C double bonded O, which of course is the carbonyl group, not an alkyl group, so that doesn't work. The answer is B. Next one, which of the following is an alkanote molecule? Actually, it's the first one this time because we have a carbonyl group connected to an O and an alkyl group, which is CH3. Choice B, you don't have the carbonyl group. Choice C, we have the carbonyl group connected to an OH group instead of an alkyl. That doesn't work. And this one, missing a carbonyl group. Example 3, which of the following is an alkanone molecule? And the answer is on the next slide. The first one, we have our carbonyl group, which is great, but it's connected to an O on one side and not connected between two alkyl groups. The second one, here's carbonyl, and here's our two alkyl groups, so that's just fine. That's going to be our answer. C, we have a carbonyl group connected to an O on one side, okay, and not connected between two alkyl groups. And finally, there is no carbonyl group here. Which of the following is an ether molecule? All right, part A is okay with this piece. We have O single bonded to an alkyl group on the right, but it's a carbonyl group on the left, so that's no good. Here, we don't have a single bonded oxygen. And here, we have the oxygen single bonded to an H on the left and a carbonyl group on the right, so that's not it. And finally, at the bottom, we have O singly bonded between two alkyl groups, so D is our answer. Which of the following is an alkanoic acid molecule? The first choice is missing the OH group, so that doesn't work. Second choice, same thing. Third choice, we have our carbonyl group, the COO, bonded to a hydroxyl group, so that's perfect, that's the acid. And then finally the bottom, once again, missing the carbonyl group. Which of the following is an alkanal molecule? The first choice is no good. We don't have the CHO group. We don't have one over here either. Finally, for part C, choice C, we have a CO group, carbonyl group bonded to an H, which is also shown as CHO and that is bonded to a terminal carbon over here. So this one's good. And here, let me make those X's. And finally, we don't have a carbonyl group bonded to an H, so that is incorrect. The answer is C.